Alright, so this is our video lesson for Chapter 1. Now, the way the video lessons are going to work is they're posted on YouTube. I'll put the links on my website so you can find them. But video lessons are when I'm going to teach you through a video. So in class, I will not be covering this material. So if you don't watch the video lessons, then you have to get it on your own. Okay, so this is Chapter 1. Super easy because it is Introduction to Chemistry. So in Section 1, we're just going to kind of touch base on chemistry, and we'll talk about some of the different types of chemistry, the different branches and things like that. So matter is anything that has mass and occupies space. So for example, this table is matter. For example, your textbook is matter. They both have mass and take up space. But what about air? Would air be matter? Well, let's think about it. If you blow up a balloon, does it expand and take up space? Yes, it does. And can air press down on us and make us feel air pressure? Yes. So that means it also has mass. So air would also be matter. Now, what about something like light? Would light be matter? Well, light is energy. It's not matter. It does not have mass and it doesn't take up space. If light took up space, then if we turned on a bunch of lights all in the same room, then technically it could fill the room up with light and then no more would fit. And we all know that doesn't happen. Okay, so light is not a form of matter. So matter is anything that has mass and takes up space. Now chemistry, of course the class that you're in, is the study of the composition of matter and the changes that matter undergoes. So in other words, what we'll be learning this year is what happens when matter turns into different types of matter. Okay, so like we might start with a solid and what happens when it becomes a liquid, it changed state. Or we might study a reaction, like what happens when I drop copper into nitric acid, what are the products? Those are the types of things that we'll be studying this year. Alright, so let's look at what's next. So next, chemistry is broken up into 5 branches. Okay, the first one is organic chemistry, then you have inorganic chemistry, biochemistry, analytical chemistry, and physical chemistry. Now, because I majored in chemistry, I took many classes in all 5 areas. Depending on what you want to do with your life, that will determine if you need to take chemistry in college or not, because that's a common question that I get. You know, if you want to go in the medical field or something science related, obviously you probably need to take chemistry, maybe even more than one. You know, but if you're going in, you know, to business, then you might not need to take it. Okay, so that would all depend on the school that you end up going to. But these are the 5 branches. So, what is the difference in them? Well, organic chemistry involves the study of all chemicals containing carbon. So carbon is C on the periodic table. Now, I know you don't have the periodic table memorized, but everyone should already at least know what C is. Okay, so carbon is C on the periodic table. So anytime we study molecules or chemicals that contain carbon, so you can see that there are C's in this molecule, that means it contains carbon, that falls under organic chemistry. So it's focused on chemicals with carbon. So for each branch of chemistry, I'm going to kind of give you a little way to remember it. So if you'll just remember organic has carbon, then you're good to go for that one. All right? So let's look at what some of the other branches are. So organic is the study of chemicals that have carbon. So inorganic would be the opposite. So inorganic chemistry involves the study of chemicals that do not contain carbon. Okay, so for inorganic, we have no carbon. All right, so organic has carbon, inorganic has no carbon. So for example, if I was studying, you know, potassium hydroxide, which is KOH, there is no carbon in there, so that would fall under inorganic chemistry. All right, the next one is biochemistry. Now, you should all have had biology, which biology is what? The study of life. So bio means life. So in other words, biochemistry would mean life chemistry. So what kind of things should that make you think of? Well, chemistry is the study of reactions. So it means it's the study of reactions that occur in living things. Okay, so it's the study of processes that take place in living things. So if you'll remember that bio means living, then that's an easy way to remember that one. Okay, so organic is carbon, Inorganic, no carbon. Biochemistry would be living. So for example, if I was trying to study how an antacid neutralizes stomach acid and helps reduce things like heartburn, that would be an example of biochemistry. All right, so let's look at the last two. So the next one is analytical chemistry. So analytical chemistry focuses on the composition of matter. So what I mean by that is that's kind of a mystery question. Like, I found this mysterious substance, what is it? That would fall under analytical. Or like things like water quality. You know, how much lead is in this drinking water? Because lead's poisonous, so we don't want a lot. We really don't want any. You know, if I was trying to analyze, you know, how much of something was in my drinking water, that would be an example of analytical chemistry. All right, and then physical chemistry has the weirdest, longest definition. Okay, it is the area that deals with the mechanism, the rate, and the energy transfer that occurs when matter undergoes change. So again, y'all, just pick out one word. Okay, pick out like a key word to help you remember. So rate is a nice short word, and this is the only definition that has rate. So what does rate mean? It's the speed. So if I was trying to figure out, you know, how could I speed up a certain reaction to make it happen faster, that would fall under physical chemistry. Okay, so if you remember, organic is carbon, inorganic is no carbon, biochemistry is living things, analytical chemistry is the composition, and physical chemistry deals with the rate. That's how you can keep them all, you know, separate and know what each of them means. All right, and so we'll be kind of going a little bit into each area because this is just intro to chemistry. So in other words, we'll just be doing a little bit of the basic stuff out of a lot of different branches. All right, so let's move on and look at a sample problem that I might ask you about the branches of chemistry. And that would be to give you some scenarios, and then you have to determine what branch of chemistry it falls under. All right, so it says, which branch of chemistry would the following belong to? So it says, a police officer testing a white powder. So in other words, obviously, someone probably got pulled over. They had a little baggie of a white substance. Police officer's like, oh, what's this? The person's like, oh, it's baking soda, you know, because we all carry little baggies of baking soda around with us. So, police officer goes back to the patrol car, pulls out a little test kit, dumps the powder in there. Uh-oh, it turned blue. Wasn't baking soda after all. Okay, so in other words, he's trying to determine what the substance is, the composition of the substance. So this one would fall under analytical. If you'll remember, analytical sounds like analyze, then that can help. He's analyzing the powder to figure out what it is. All right, next one. The study of hydrochloric acid in the digestive system. Okay, for those of you who don't know, your stomach acid is hydrochloric acid. So if we're studying your stomach acid, which is in a living thing, it would of course fall under biochemistry. All right, the next one, it says determining the speed with which a reaction takes place. So the key word here is the speed. What that should make you think of is rate. And rate is our key word to remember for physical chemistry. All right, our next one says the study of glucose. Now, you should know glucose from biology, C6H12O6 from photosynthesis. But I know some of you probably forgot, so I was nice and gave you the formula. So since it contains C, what would this fall under? It would be organic chemistry. Because remember, organic chemistry is the study of compounds that contain carbon. All right, and then the last one, it says the study of calcium deposits from hard water. So here we're studying calcium, which is not carbon, so this would fall under inorganic. Now, can you ever have a scenario that falls under more than one? Of course you can. Because really, this last one, if we were trying to determine how much of the water is calcium, like how much calcium is in the water, then technically that could also fall under analytical too. So on a test, I'll try to give you ones where it's real obvious which one I'm looking for. I won't give you those ones where, you know, there's a few different ones that you can pick from. All right, so let's move on. Hopefully you found this part pretty easy so far. There's our answers, by the way. If you couldn't read any of my writing on that, there's our answers in order. So let's look at our section assessment. Okay, so section assessments, we'll just do these together. They're just questions at the end of the section to kind of wrap it up and bring it all together. So it says, name the 5 traditional areas into which chemistry can be divided. Okay, so we have organic chemistry, inorganic chemistry, biochemistry, analytical chemistry, and physical chemistry. Okay, so those are the 5 branches. All right, so let's move on to section 3. We skipped section 2 because it's on stuff that we don't need for our standards. All right, so section 3, we're going to talk about kind of the history of where chemistry came from. So long ago, there weren't chemists, there wasn't chemistry, there were alchemists, and they practiced alchemy. So alchemists searched for a way to turn a cheap metal like lead into gold. So gold is valuable to us today, but long ago it was so incredibly valuable. That was their money, of course. So if an alchemist could figure out a way to turn something really cheap into gold, I mean, you could become rich beyond your wildest dreams. So as you can imagine, this was a really cool concept that a lot of people jumped on board. Like, ooh, I think I might be able to make gold. You know, I know how to do reactions. Well, the problem is their idea was impossible because one element cannot turn into another element by physical or chemical means. So in other words, they spent all this time, all this energy, some of them spent their entire lives trying to do this one thing that was completely impossible. Okay? And then the problem was because, again, you know, they weren't just doing this. They had their labs set up and they would do all kinds of reactions. And so eventually some of them, they would start creating like potions and elixirs to do things like extend your life and make you young again and all that kind of stuff. And a lot of them end up killing a lot of people because their potions were poisonous. A lot of them tried their own potions and ended up killing themselves or getting really sick over it. But, so you may think, well, why in the world are we talking about them if their lives were complete failures? Well, the thing is, even though they never did their goal, they did help us out. Okay, so let's click and look at what they did do. So even though they were unsuccessful in creating gold, because that's not going to happen, they did develop tools and techniques that we still use today.
Mr. King and Mr. Parham, you're needed in room 517 for a meeting. Mr. King and Mr. Parham, you're needed in room 517 for a meeting.
Okay, so I make these videos before and after school, so just get prepared for the intercom line. Alright, so again, even though they were unsuccessful in creating gold, they made the tools and techniques. So a lot of the equipment that they came up with and the techniques they use, like distillation and those type things, we still use in lab today. We just use them for things that are actually possible. We're not trying to create gold anymore. Alright, so that's why they were important, because they did help us out in the long run with their equipment and the procedures that they used. So let's talk a little bit about scientific method. Now I know it's unfortunate that every time you learn scientific method, the steps are slightly different. So I've learned lots of different steps over the years, so I tried to pick kind of the common one that I see over and over and over again, and that is this 5-step set. Okay, so our first step is ask a question, or you could state a problem. Either one will be fine. Our second step is we need to observe our surroundings or research or something like that to find out a little bit about our question or problem. Our third step would be to form a hypothesis. Now, a hypothesis is not just an educated guess. See, it continues. It is an educated guess based on observations. So that's why observe has to be step 2. A lot of people want to do hypothesis as step 2. But we have to observe first. I can't just say, I don't know what's going to happen, but I think it's going to be this. That's not a hypothesis. That's just a guess. Okay, so we have to observe or research to get an idea of what's likely to happen. Then we can form a hypothesis, which is based on our observations. After you hypothesize, you actually carry out your experiment, which you can also say collect data, because that's what we do when we experiment. And then once you're done collecting data, you draw a conclusion, or sometimes it's referred to as analyze your results. So either one of these is fine for step 4 and 5. Okay, you can do experiment or collect data, conclusion, or analyze results. So we have question, observe, hypothesis, experiment, conclusion. Those are the 5 steps. Okay, question, observe, hypothesis, experiment, conclusion. 5 words to get through the whole scientific method. All right, so let's talk a little bit about doing an experiment. Okay, when you do an experiment, you have variables. You have a manipulated and a responding variable. Now, some textbooks use the term independent and dependent, so I'll put them together so that way if you're used to that, terminology instead, it's right here. Okay, so the manipulated variable, also known as independent variable, is the variable that you change during an experiment. So if I was trying to see, I have a group of plants that I'm going to put out in the sun. I have a group of plants I'm going to put in a dark closet, and I want to see who lives the longest. Okay, well, what did I change during that experiment? I changed the light, like some are in the sun, some are in the dark. That's what I changed. So my manipulated or independent variable would be the amount of light they receive. Some receive sun, some don't. All right, the responding variable, also known as the dependent variable, is the variable that you observe or measure during the experiment. So in my example of the plants growing outside versus in a dark closet, what would I be measuring or observing would be the plant itself. Like I could be measuring how tall they grow, or in this case, because we all know that the plants in the dark are just going to die, I could be measuring life versus death. Any of that would be fine. Okay, so manipulated or independent, you change that between your different groups, and responding is what you're looking at or what you're measuring. Now, a good experiment has only one manipulated variable. Okay, diet pill commercials are extremely common. And they talk about, oh, I took hydroxycut and I lost 47 pounds. Well, most of the time, if you read the fine print at the very bottom of the TV screen, it says that they also did a diet and exercise program. So you lost 47 pounds, you took the diet pill, but you also started exercising and dieting, which we all know makes you lose weight. So then we don't really know, well, how much weight did you lose just because of the diet pill? Because they changed more than one thing. They started taking the diet pill, they started exercising, and they started dieting. So those are 3 things they changed. So we can't attribute the weight loss to any one part. All right, so that's why a good experiment, one thing you change. All right, so let's talk about the difference in a law and a theory. A bunch of my students in the past had trouble with this, so I came up with this little easy way to remember. Okay, so first let's look at kind of the book definitions of the words. They're kind of long and wordy, a little hard to understand. So hopefully my little statement at the bottom will help bring it together for you. So a theory is a well-tested explanation for a broad set of observations. So in other words, y'all, a theory is something where we get the same result kind of over and over again. So we can come up with a theory as to why it's happening. Like, the theory of evolution. That would be an example of a theory. A scientific law, on the other hand, is a concise statement that summarizes the results of many observations and experiments. So scientific law is me just saying, okay, every time I do this reaction, this happens. So like law of gravity, every time the apple comes off the tree, it falls down to the ground. We didn't try to tell why it fell to the ground. We just summarize what happens. The apple falls to the ground. Whereas a theory is us kind of trying to explain something, okay? So see how it's an explanation? So the easy way to remember it is a theory is an attempt to explain why something happens. And the easy way to remember that is theory has a why and why has a why. On the other hand, a law just tells what happens. So the easy way to remember is law has an A and what has an A. Okay, so if I just say the apple falls, that's just me saying what happens. That's a law. If I try to explain why the apple falls, that is a theory. Okay, a lot of people, they want to say, well, a theory is not proven, a law is proven. It doesn't have anything to do with that. Theory is us trying to explain why or how something happens. A law is just saying, this is what happens. No explanation, this is just what happens. All right, so let's move on to our section assessment. So, name the 5 steps of the scientific method. Well, we just did them. Okay, you start with question, observe, hypothesis, experiment, conclusion. Okay, you just wrote them down in your notes, so I'm not going to write them up here. Okay, question, observe, hypothesis. Difference in a theory and a hypothesis. Okay, so we just discussed the difference in a theory and a law, so now let's do theory and hypothesis. Okay, so remember, we said earlier that a hypothesis is an educated guess based on observations. Alright, so it's an educated guess based on observation. So in other words, you don't know what's going to happen. You're trying to predict what's going to happen. It's a prediction. Whereas a theory is a well-tested explanation for why something happens. So I'm going to shorten that just to save time and put a well-tested explanation. Alright, so in other words, the hypothesis, you are going to test it. A theory has already been tested. Okay, so that's the difference. So in a hypothesis, we're forming a prediction of what's going to happen. In a theory, we're trying to explain something that's already happened. So you can kind of do it like this. Like a hypothesis is a before thing. Like we don't know what's going to happen yet. Whereas a theory is an after. Okay, we've already seen what's going to happen. It happens over and over again. Why is it happening? Alright, so last one. In chapter 2, you will learn that matter is neither created nor destroyed in any chemical change. Okay, we're going to learn that in the next chapter. Is this statement a theory or a law? Explain. Okay, so let me read the statement again. Matter is neither created nor destroyed in any chemical change. So what you need to think of is, am I telling you why, or am I just telling you what happens? If I say matter is neither created nor destroyed, I'm just saying what happens. I'm not telling you why it's not created or destroyed. I didn't say matter is neither created nor destroyed in any chemical change because blah, 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 blah. I'm just making a statement. Matter is not created or destroyed. So that would be a law, because it is just stating what happens. Okay, it's not trying to tell me why. It's just stating what happens. Alright, so let's move on to the last section of chapter 1. Hopefully you are finding chapter 1 pretty easy, and hopefully a lot of the stuff you kind of already learned before. Alright, so unfortunately for some of you, chemistry involves a lot of math. Okay, now we don't do complex math, but some of y'all will end up struggling with the math. So we're just going to kind of do a little review of how to kind of do a math problem. We're not going to get into the math yet, that'll come later. So there are 3 steps to solving a numeric word problem. So in other words, a math problem. They are analyze, calculate, and evaluate. So let's talk about what these are. Now most of y'all, you do these naturally in your mind when you're doing a math problem. You don't stop and say like, oh, I'm about to analyze. Okay, next I'm going to calculate. This is just the natural progress that you follow when you're doing a math problem. So analyze is identify the known and unknown. Y'all, the easiest way to identify the known and unknown is something really easy. Read the problem. A lot of you want to pick out the numbers and then just say, oh, do I multiply or do I divide? Okay, you've got to read the problem. Figure out what they've given you. Figure out what you're looking for. Alright, step 2 is solve the problem. This is where you actually do the math. In chemistry, most of the time, this would mean you're plugging it into a formula. Not all the time, but most of the time. Alright, and then last step is evaluate. Is your answer reasonable? So sometimes you can evaluate. Like if I said, you need to calculate the speed of this car, and you calculated that it was 1.7 million miles per hour. Does that make sense? No. That's obviously way too fast. Or if I calculated the speed of the car was negative 56 miles per hour. That doesn't make sense. Now, can you always tell if your answer is reasonable? No. We've all had those math problems where you're just lucky you even got an answer. You have no idea, is it supposed to be positive, negative, large, small, a fraction, a whole number, and you're just lucky to get an answer and move on. But when your answer seems unreasonable, then go back and double check it. Okay, for example, if I was trying to calculate how many seconds I've been alive and I got 3, that clearly doesn't make any sense, so I would go back and retry. And then as opposed to math questions in your math classes, in science, our numbers always have a unit. Okay, so you shouldn't be putting answers like 16. 16 what? Is it 16 miles? 16 seconds? 16 kilograms? Like, you have to put a unit, and I will work with you on how you know what unit to put where. Alright, so let's go ahead and click and knock out this assessment. So our last slide for this chapter. So it says, list the 3 steps for solving a numeric problem. Okay, well the first one is, of course, analyze, then calculate, and evaluate. Analyze, calculate, evaluate. So analyze is pick that known and unknown. Calculate is do the math problem. Evaluate, check your answer. Okay, like I said, that's the normal progression that you follow when you're doing math problems anyway. Alright, so here is an actual math problem, just for us to practice the 3 steps real fast. Okay, again, I'm not going to jump into math all of a sudden. We'll get into math when we get to chapter 3. Alright, so it says there are 3,600 seconds in an hour. How many seconds are there in one day? So part A says identify the known and the unknown. Okay, so what we'll do is we'll underline the known and we'll circle the unknown. Alright, so the known is what they tell me. So what did they tell me? Well, they told me there are 3,600 seconds in an hour. That's what they told me. So I know there are 3,600 seconds in an hour. The unknown is what am I looking for? What are they asking me? So they say, how many seconds are there in one day? So that is my unknown. Okay, we know how many seconds are in an hour. We don't know how many seconds are in one day. Now, technically, there is another known that they didn't tell me, but you should already have in your mind. What else do we need to know to answer this problem? We need to know how many hours are in a day. And see, that's something you should already know. So our other known would be how many hours in a day? 24. 24 hours equals one day. Okay, so that's something that they didn't tell me. That's something I already knew myself. So it still counts as a known. You can have more than one known. That's okay. There's lots of times I'm going to give you multiple knowns. All right, then it says calculate the answer to this problem. Well, we know this many seconds in an hour, this many hours in a day. So what am I going to do? I'm going to multiply my 2 numbers. Okay, and when I do that, I get 86,400 seconds in one day. All right, so our last step is evaluate your answer to see if it makes sense. Well, we're talking about seconds in a whole day. So does it make sense there's a whole lot of seconds in a day? Yes, like if I ended up with 17 seconds in a day, clearly that would not make any sense. Okay, so the fact that there would be a lot of seconds in a day and I got a large number, that makes me feel confident that my answer is probably correct. And then don't forget, notice I put my unit here, seconds. Okay, you've got to have units. I count half off every time you leave off or put incorrect units. So just get used to that. All right, so that should be the last slide. Let me just double check. All right, and the end. So look forward to watching the chapter 2 videos because we'll have some of those also. And just know that any of the chapters where they're kind of hard or the math chapters, I teach those in class. Okay, so I don't want you feeling like you're going to have all your lessons on videos. It's just the easy lessons I do on videos so we can use more class time for practice. All right, so we're done.